I am Yusuf Abdullah Mahfuz. This is my lab 3 for my course Computer Organization and Architecture section 6. So in this lab question we are given with 11 problems to solve. So we will be using Visual Studio 2010 as a tool for solving these questions. I am going to video the question number 1 of lab 3. So I am going to build the project now. Now F11. I need the windows to analyze my result. First I bring the register tab, then I bring the autos tab, then I bring the memory 1 tab. Okay, then I am going to compile one by one each of this line. So here it shows the registers and here it shows the flags. If I execute line 1, it shows for this line move AX 10H. Here two flags are available. One is ZR flag. ZR flag is basically the 0 flag, and another one is EI flag, and another one is PE flag. Then I'm going to compile the next line. For this line it shows no 0 flag and it has PE flag. Then I'm going to compile the next line. For this line add AX, 15H, AX, 15H. Here I have PL flag, EI flag, AC flag and CY flag. CY flag is the carry flag, ZF is this is the 0 flag. Then I'm going to compile the next line. Here for this line add AX, 112. Here only one flag available, this is CY flag. Then I'm going to compile the next line neg AX. For this line we can see AC flag, PE flag and CY flag is activated. Then we compile the next line for move BH, 66H. For this line PL flag is activated, CY flag activated, AC flag activated and PE flag activated. For next line INC BX, this means that BX is incremented, 1 is added with BX. So for this line CY flag is activated and all the flag is 0. Then we compile next line using F10. For this line mul DH, here 0 flag is activated, CY flag activated, PE flag activated. This is parity flag. Parity flag 1 means odd number of 1 is there. Then we compile the next line. For this line sub AL, 3, AC flag is activated, parity flag activated and all the flag is 0. Then I'm going to fill this table using the information I got from the register tab. This is question number 2. Here this question wants two results. One is add AL, 92H and another one is add AL, 127. So we need to show the value of these two statement, also the OF flag. So I compile the first statement, which is move AL, 80H. Then I'll compile the next statement, which is add AL, 92H. So if I compile this statement, I can see that the value, that means AL equals to 18 and the OF value is 1. So I continue compiling. After compiling the line add AL, 127, we see that the value AL equals to decimal 125 and OF value is 0. This is question number 4. This question asks about the register value. So if we compile the statement, then from the register tab we can see the register value of the following line. So the first statement is move AL, PKP. If we compile this line, the register tab shows EAX equal to, the address is 0B. Then we compile the next line, which is move AL, PKP plus 3. For this line, the register is 2D. For next line, move AX, zoom. For this line, the register is 002D. For line move AX, zoom plus 3, the register address will be 4400 hexa. For line move AX, zoom plus 4, the memory address will be 0444 hexa. For line move EAX, padlet, the register address will be 0 hexa. I mean this will be 80, I mean total 80 hexa. Then the next line move AH, PKP plus 8, the register of this line will be 04 hexa. For line move EAX, 0, the register will be all 0 hexa. For line move AX, zoom plus 2, the register will be 0045 hexa. For line move padlet, EAX, the padlet equal to 0000 0045 hexa. This is question number 6. In question number 6, it asks, referring to the array definition in question 3, write a program to sum array PKP. So the contents of array PKP is byte 11, 22H and 4AH. So we need to do the summation of this code. So after build the program, we move on to compiling. So if we compile, for example, if we compile the first line, we can see the register is updated after each compilation is done. So when we compile move AL, PKP, the register EAX is updated because EAX is a part of AL register. Then if we compile add AL, PKP plus 1, the register EAX is again updated. So after compiling the next two steps, when we compile the move total, A1, the register EAX is showing the total value. So the final value is 77, which is shown in register EAX. If we write total in watch tab, it shows 119. 119 is the decimal value of hexa 77. This is the summation of total. So in the code, at first we move PKP in AL, then we add AL with PKP plus 1. PKP plus 1 is actually referring the address of 22H. Then we again add AL with PKP plus 2. PKP plus 2 is referring the 4AH. Then finally we move AL into total. Total is an empty variable. We declare total as byte 0. This is my video for question number 6. This is my video for question number 7. In the question number 7, the question asks for the summation of zoom. So the element of zoom is word, 45 decimal, 45 hexa, 444 hexa, 4A 4B hexa, and 44A hexa. So at first we write down the code, then we build the code, and if we compile, finally we will get the total value. So at first we move AX comma zoom, so it will place the value of first element of, it will place the address of first element of zoom to the AX. Then if we add AX with zoom plus 2, it will add the second word element of zoom with AX. So continue like this. If we go finally zoom plus 8, so zoom plus 8 is the last element of zoom, which is 44AH. So if we compile the first element, so now AX is loaded with address of zoom. Now if we compile the second line, AX comma zoom plus 2, here AX is added with the decimal value 45 and hexa value 45H. So like this, if we compile the rest of the code, and finally we go to the last line, which is move total comma AX, so we can see that the EAX register tab showing the final value, which is 534B. 534B is the value of total. So this is basically the summation of zoom. The equivalent decimal value is 21323. So we can say that the sum of zoom array is 21323. This is question number 8. In this question, it instructs us to observe the given code. So we type the code into the compiler, and we will see the memory address of EDI, ECX, and finally the result of total through the execution and debugging process. So let's move on to the code. We compile the first line. So through this compilation, we will find the memory address of EDI. So as shown in the register tab, the memory address is 004040000. So after the compilation of next line, we will find the memory address of ECX. This memory address of ECX is 00000004. So let's move on to the next question. Through the execution of this line, here basically the address of EDI is updated. Previously the address of EDI was 00404000, but now this address becomes 00404002. So this is 2 more than the previous address. So we can say that EDI equals to EDI plus 2. Now after the compilation of next process, here a loop runs. So after the loop ends, we will find the value of total. So the value of total as shown in the autos tab is 2560. So if we transfer the value of this total from decimal to hexa, this will be 0A00. This is question number 10. The assembly code is given in the question. The question asks us to show the final result of total. So if we compile the code, at the end of the compiling, we will get the result of total. In this code, they have used a loop L1, and counter is given as dword7. So when the compiler finishes counting, it will exit from the loop, The counter here is dword 7. So let's move on to the code. We will start compiling. So after the first line execution, we can see the register is updated. The autos here, EX is assigned with 0, ECX is assigned with the address of counter, and counter here shows its value 7. So we move on with the execution. Here the loop starts and it's counting and the loop continues. So when the counter finishes its counting, the loop exits. Now the whole code compiling is done, and we can see the total is showing its output. So the final value of total is 112. Here 112 is a decimal value. If we convert the decimal value into hexa, that would be 70 hexa. That is equivalent to 112 decimal. This is lab 3 question number 11. This question asks us about need to write a program to achieve the following equation, which is 100 hexa into 7 hexa. So we need to do this. We need to find this equation using a loop instruction. So 100h multiply with 7 hexa, this becomes 700 hexa. So the equivalent of 700 hexa decimal value is 1792. So we need to achieve this result in the autos tab of this code. So let's move on to the code. So we have already write down the code. If we compile line by line, let's check what happened. At first we build the program and now move on to the compilation. Here the loop is going on. Okay, if we see, look at the autos tab at the EAX and total tab, total section, the total is 1792. So basically this 1792 is a decimal value. Its equivalent hexa value is 100 hexa into 7 hexa, which is 700 hexa. So finally I am done with doing all the lab exercise of my lab 3. So here was total 11 questions from question 1 to question 11. So just before the question in the lab 3 they have gave us some concept. So after reading this I got knowledge about flag, register, memory, jump and many other things. So this lab was all about chapter 4, which was assembly language instruction sets, characteristics and function. So I got a clear idea now about this chapter. I have learned how to use mnemonics, register usage according to different data types like word, dword, byte, sbyte, etc. Other than this, the memory usage, register usage, etc. is clear now. I have also got idea about array. So I know now how to solve an array, how to sum an array and do other things. Jump concept is also clear to me now. I have also learned about the looping process. So from here my question starts. Question 1 was all about flag. Question 2, question 3 is related to flag also. Question 3 is writing the instruction sets. Question 4 was all about register. So I just write down this code given in the question in Visual Studio 2010. Then I built the project and using the register tab I got those values. Question 5 gave us the value we need to write down the code. Question 6 was array of a question 6 was sum of an array. Question 6 was sum of an array. Question 7 is similar to question 6. Question 8 wants us to write down the register value. This is question 9 and question 10. So question 11 wants us to write down a program using looping concept. So this lab helps me to clear my conceptual problem in a greater way.